Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting-edge research, and inspiring interviews with experts, enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today I'll be interviewing Chang, who holds a bachelor's in electrical engineering from Caltech and a master's and Ph.D. in electrical engineering from Stanford. How are you doing today?
Good, good. Thanks for inviting me.
And thanks for coming on the podcast. So to get started, I kind of wanted to ask what you were interested in high school and what made you end up at Caltech.
Wow. Okay. Just trying to think back. Um, Interest in high school. I was very much in the, math and sciences, as you can kind of imagine. Um, I do remember always looking forward to my classes. I took all um, biology classes, chemistry, physics, and all the different math classes. And I've always felt comfortable and really enjoyed the topics. So I think I naturally just kind of went in that direction.
Mhm. Yeah. So what was your experience like while at Caltech?
At Caltech,
Yeah.
Caltech was a great experience, but also one of the most challenging, or I would say the most challenging experience I've had.
Mhm.
Both just the caliber of people is so great, but also, everyone's are great people as well. And so I felt, despite being doing well in high school, I felt I was, middle to bottom of the pack when I got to college. And that I remember for a lot of people felt that way. And so it was very humbling experience, but also very good, the one where you kind of learned, okay, like, with a lot of these new challenges, how can I learn to persevere? How can I learn to learn? That's what I would say came out of the college experience at Caltech was learning how to learn.
Obviously, Caltech's definitely a rigorous college compared to most,
Mm.
especially when you're doing those intense STEM courses you got to take for electrical engineering. So, when did you decide on electrical engineering? Did you already know that going in, or did you change your mind while you were there?
I kind of actually knew. So my dad was an electrical engineer, so that kind of helped. I kind of understood at a high level what that meant. Part of it was maybe I wasn't necessarily I knew I wanted to do it, but I liked the idea of it when we're talking
Mhm.
about kind of when I kind of learned what it might entail. So I kind of just went with, okay, that doesn't seem bad. I'll just go with it. And if I don't like it, I could switch. But it turned out I really liked it, so I just kept going with it.
Yeah. So, when along the way do you realize that you want to do a master's and keep going on with the education?
Yeah, so for me, Caltech, the culture is very academic oriented. So what I mean by that is, at least back when I was there, the default for anyone graduating is to go to grad school. I think for most universities, it's the default is to go and work, right? Go get a job, go work in industry. But the default there is to go into academia, right? And eventually, try to get an academic position. So for me, my thought process was I really like learning. I'm not burned out. Let's just keep going. Because I know once you get a job in industry, it may be a bit harder to come back to school, right? It's a little more challenging. So I felt like if I have momentum, I'm just going to keep going with it. And so for me, it was just naturally really still interested. Let me just keep pursuing. And so I just went with it.
Yeah. And did you already decide on the PhD, or were you just thinking about the master's?
Yeah, pretty much.
Mhm.
I was thinking, yeah, because in the application process, at least for the ones that I applied, you do need to indicate your intention, whether it's just master's or you're trying to get the PhD and get the master's along the way, because they may treat it differently, the application. So I signed up for PhD right away.
Yeah. So, what was your research about?
My research was in the world of, even though I have an electrical engineering degree, that's a very broad topic. It can mean many things when you ask someone and they say they're an electrical engineer. You could be in neuroscience, you could be in circuits, you can be in information theory, you can be in computer systems, you can be, in machine learning, all sorts of types of things. It's a very broad set of skills. But for me, from my research in college, I was looking at photonics, so applied physics. I was in the applied physics world, and I had done research in photonics. And so I kind of extended that. And so my research was I found a professor um, that was doing research in a field called nonlinear optics. And so that's basically the high level idea there is you're playing with laser light for the most part, and you're doing all sorts of light manipulation, things like changing colors of light. You can build all sorts of really creative, a lot of technologies that we have in our phones today, how we communicate fiber optic cables and those things. Those are all photonics type of concepts, research, and technologies. So that's kind of the world that I played. My specific research, I actually worked on a project with Lawrence Livermore National Lab. They are a premier research, national lab located in Livermore, just south of Berkeley in the East Bay, and East Bay, California. And they they were trying to, at the time, they were building the National Ignition Facility, NIF, NIF. And that's a really cool project. It's started in the 90s, it's still going today. They're trying to recreate the fusion that happens at the center of the sun. They're trying to recreate it on Earth, right? And so what that entails is this huge building that's about I remember taking a tour before they closed it off. It's 3 football fields, the size of the building. It has 192 laser beams. Each laser beam is the size of a human person. So think about a huge laser beam, and there's 192 of them. And then they point all of that energy into a single point where there's a target, like some kind of fuel. I don't really understand the physics too much, but by shining all the energy onto this fuel, they can create fusion. And what happens is you get a bunch of a reaction, X-rays, and all sorts of electromagnetic waves coming out of it. And so, in order to understand what happened, right, as an experimentalist, you need to be able to measure these type of high frequency, high short time scale um, reactions. And so to measure that, that takes technology where electronics is actually too slow to measure. When you talk about, yeah, electronics, usually you have a gigahertz speed, which is 10 to the minus 9 seconds. But for reactions of this length, you have 10 to the minus 12, 10 to the minus 13 time scale. So your electronic equipment is actually 10,000 times too slow to measure some of these things. And so there are technologies where my research was involved is you can actually um, create a time microscope. So what that means is imagine a normal microscope where you take a really small object and you can image it to something bigger that you can see, right? That's what a microscope is. You can look at something really tiny because it's making it bigger, right? You can actually do the same thing in time where you take a really short pulse of light or a time scale object and you can stretch it in time, right? So it's kind of like if I say something like really fast, that's hard to hear. But if I say something really fast, like I say, slow it down, it's easier for it to hear. So same thing, you can do it. You can do this magnification in time. Turns out you can do that. The it's a physically a different system, but the math to do it is the same. And so the idea is that you can stretch out these pulses to be very long, and now you can use slower equipment like electronic equipment, like oscilloscopes and things like that to actually measure these waveforms and understand what happened during those type of experiments on this big, type of national lab scale, right? So my research was focused on how do we build the microscope and understanding aberrations and properties of such a what we call a time microscope so that it can be useful for these type of applications. So that was a long-winded answer to your question. Hopefully that kind of made sense. I tried to make it be able to explain it quickly.
So, as that was like a super kind of novel technology then. I'm
Mhm.
guessing at the time at least it didn't have much commercial use. We're
Mhm.
about to talk about your jobs. Were you able to continue using all of that work? or did you kind of change directions?
I changed directions. It's really interesting. I really enjoyed doing that from an intellectual standpoint, right? It was just really interesting to do, learned a lot. But when it came down to the day-to-day nuts and bolts, I found that um, I didn't want to spend all my time sitting in lab tweaking mirrors. That's what I did with lasers and stuff like that. You're like tweaking mirrors and you're trying to align things. You're run these experiments. I enjoyed it from a school standpoint, but not like a career standpoint. So at the time, I started looking around. I actually considered management consulting, working at companies like McKinsey and Bain and things like that. But turned out data science was this new field. I wouldn't say new field, it was a new concept or this new term that started getting a little attention at the time. This was around 2013, 2014. And so I liked the idea of it because one, it kept me technical. You can still be very technical, which I liked, but it also gave me the freedom to learn about the world, go see different problems around the world, look at different companies, different industries. Had I stayed on the track that I was in research, I'd probably be working at a laser company and really focus in a very narrow area. But right now, I get to see a whole breadth of things and get to appreciate kind of the world around me. So I do like that's kind of the big reason and still holds true today why I switched.
So what sorts of areas do you look at today?
So can you repeat that
So what kind of areas are you looking at today then?
in terms of types of projects I do or
Yeah.
okay. Yeah, so just a little background. I run a data science consulting firm called Stratus Data now, which allows me to kind of, explore all these companies. So in the past several years, we worked with companies large and small, subsidiary of like Disney and Kroger, all the way down to small startups. We've worked in many different industries like medical devices, where we built algorithms for really novel hardware concepts that these companies are building, and they needed help building algorithms to take the data and map it onto like, does this person have this or, things like that. We worked in some real estate, we've done manufacturing, we've worked in retail. So it's all sorts of things. And now we're starting to focus more on kind of the manufacturing and distribution type spaces.
Yeah. So, what was the whole process like starting something like this by yourself?
Yeah. So luckily I have a co-founder.
Mhm.
His name is Charles, and that makes having co-founder is really nice. It makes things a lot easier when you do something um, with someone you trust, and you can get more things done. I would say it's being an entrepreneur has, it was kind of a leap because you're trying to start something that you don't know if it's going to work. You also don't know, if you're going to make money, right? In order to, at the very least, put food on the table, right? Long term, right? So I think that was always a risk. Part of a risk, at least for me, um, is, and just also knowing family, like the concern of, hey, Derek, you spent all these years in college, grad school doing, physics, and then now you're doing nothing related to that. That could be a little bit strange for some people to hear. Like you worked hard for something and then you're doing something completely different. And my kind of response, is yeah, I guess it is different on the surface, but a lot of the skills that I learned in school are still applied today. From like how do you approach problems? How do you technically solve some of these problems? Kind of the math and engineering concepts. Um, and I would say the biggest thing is actually how do you approach problems, right? The type of work we do is taking an open-ended problem, just like research, and being able to break it down and figure out how to solve it when no one's solved it before, right? That's literally what a PhD is. And so being able to apply that again in the type of work I do is pretty cool.
Yeah. So, what are your future goals with the company?
Future goal. Our goal right now is both to grow the company in terms of, size, but also build a company that we really enjoy working at every day. and that everyone else enjoys working in every day. So culture is really important to us. Um, it's very intentional. I think there are many ways to grow a company. I've seen companies grow really fast. I've seen company and grow well. I've seen companies, don't do as well. I've seen companies where people don't like to work there, right? It really just depends on what you make of it. And so, Charles and I early on a made it very intentional that we want to build a company that cared about its people, and that every day when we wake up, we want to, hang out with everyone on our team, like work with them, talk to them, and things like that, and not necessarily grow at the expense of that. Sometimes there's a trade-off there where you grow too fast, you can't build the culture to go with it, and the team dynamic is not as strong as it could be, right? And that's one way to do it too. There's nothing wrong with that because you could grow a faster company, right? So that's one way to look at it, but that's kind of our goal is to build something we enjoy and that we want to work at long term.
Yeah. So, as far as your industry goes, are there a lot of other companies doing this kind of consulting?
Yeah, great question. More and more, more and more we're seeing. Initially, when we started 6 years ago, not that many. There are more and more, but still a pretty wide open space. I think there's data, especially ChatGPT and AI is now becoming people are now aware, right? So of these technologies and starting to feel the pressure to need to use them. And so that's good and bad. One is it's good because now it's easier for us to talk to some companies where in the past people, we talk to them about data and how data can be useful. And sometimes they don't really get it, right? They're used to like, hey, what's not broken, don't fix it, right? So they're used to working in Excel and things like that is working. But what we try to do is work with companies to help them level up their data game, right? And make them use cloud services, provide better reporting, add machine learning and AI and more advanced analytics to really help make better decision making. And so now it's with more of this AI and ChatGPT talk, people are more receptive to these conversations. But at the same time, what that means is more companies are jumping into the world to also take a swing at the space.
Yeah. So right now, since you're wait, first of all, how big is your company?
We're pretty small. We're 8 people.
Mhm.
Yeah.
And then do you guys all work in different areas or do you have like an office or something where you're by each other?
Yeah, great question. I like to say we were doing remote working before it was cool with COVID, So we started 2 years before COVID happened. Yeah, so we're a remote first company. Most of the team is on the West Coast, so located in California and Seattle. And we do have like one or two people and a few part-time people scattered throughout the country.
And then does this job involve a ton of traveling to visit all the companies you're working with?
It doesn't right now. For the most part, Charles and I do the traveling to, do business development. For the rest of the team, occasionally they'll travel depending on the client, but most of our clients don't require us to be on site. A lot of the stuff we can, meet through Zoom, and do things electronically because it's usually data work.
Yeah. So if you had to give someone who's still in high school or early in college one piece of advice who wanted to follow a similar career path as you, what would you say?
My general advice for anyone, kind of starting out, whether it's high school or even college, right? I say this a lot to even early college graduates, is this idea of explore, exploit. Now, that's a concept in engineering that's used a lot for algorithms. And the idea here is, you're entering a world, um, you know, you're looking for a job, let's say, or looking for your career, finding out what you want to do. Don't necessarily fixate on the first thing that appears, right? The idea is that if imagine like you're an explorer, right, into a new land, and your goal is to climb the highest mountain, right? And you can't necessarily see that far in front of you. So the question is, if you start seeing an uphill climb, are you going to climb that first, right, and take advantage of it? Or does it make sense to kind of explore first to see what's around? Maybe there's something higher, a little further away that you can't see right now, right? But you might waste time climbing the small mountain when you could have spent time climbing the bigger mountain, right? There's a trade-off of your time. So that analogy applies too, where I would say spend in high school and college, really expand your horizons, try different things, take different classes that you may not think to take, or at least consider them, right? Talk to different people, especially when you're in college, right? There's people of all walks of life, different perspective. That's the best place to learn, right? Explore ideas, explore, experience things, try different things. And even when you get into the workforce, keep exploring. I would say don't necessarily, some people worry. I know I talked to some people who are like, well, I need to make money or my goal is to do XYZ. That's true, but you can do that later. The way to make money later is to be unique, is to be a scarce resource. This is economics, right? And so if you can be unique, then you're more valued, right? And in order to be unique, you need to explore and figure out where you can be unique, right? So I would say a lot of times I say use your 20s to explore and learn. Then in your 30s, once you figure out where that tall mountain is, spend your time being really good, being really experienced, go really deep, be an expert at it. That's where, from a financial standpoint, I think that's where it goes. Of course, there are extenuating circumstances. You see like people who start a company in their 20s and they make it, depends on what your definition of success is, right? It doesn't have to be financial. But I think it's important to spend the time to just explore before you spend the time to exploit. So exploit meaning going deep and going experiences. And the other thing I usually share is the question, well, how do I know when to exploit? How do I know like I've explored enough, right? And oftentimes what I'll say is, well, a lot of people say follow your passion, right? I think that's a limited view, right? I think you should follow your passion, but there's three other things that you should also kind of make sure you kind of find. One is know what you're interested in, your passion, but also know your talent, right? I think passion in a way follows talent, meaning if you're passionate about something, but you're not that great at it for whatever reason, over time, your passion will wane because it's frustrating, right? Your talent's not there. But if you're talented at something and you have a passion for it, that's self-sustaining, right? Because you're interested in it, you do more of it, you're good at it. That reinforces the passion, right? So I think it's important. So passion, talent. I would also say then you want to add experience on that, right? You need to have a level of expertise. You need to build deep expertise and be really good at something, right? So add experience. And the final thing is opportunity, which is to say, um, make sure that whatever you're passionate and you're talented at and you're really an expert at, that someone wants that, meaning there's a market for it. If you are all three, but there's no one wants it, then no one's going to hire you and no one's going to pay for your services, right? So make sure it's also something that someone wants. If you have all four of those, so I'll say passion, talent, what was it? Opportunity and experience, then that's a great recipe. Say, hey, this is a great spot for me to like dig in and spend my time. So that's a long-winded piece of advice I usually give to younger people.
Yeah, thank you for that great piece of advice, and thanks for coming on the podcast today.
Sure, no problem. Thanks for having me.